بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some review exercises about chapter 5. Evaluate the Riemann sum for this function from 0 to 2 with 4 subintervals. So the number of subintervals is 4, taking the sample points to be the right endpoints. Explain with the aid of a diagram what the Riemann sum represents. So y equals x squared minus x. We can solve the problem without sketching the graph, but since he said with the aid of a diagram, so I will sketch the graph. It's an easy graph. This is a parabola. A is positive, A is 1, so parabola opens upwards. B, the coefficient of x is negative 1. We know that h is negative b over 2a, so it would be 1 over 2, and k is f of h, so it would be f of half, so it is half square, which is 1 over 4, minus half, which is negative 1 over 4. So the vertex of this parabola is half and negative 1 over 4. And since A is positive, the parabola opens upwards. So if this is 1, okay, and this is 1, this is half, and this is negative half, and this is negative 1 over 4. So this would be x half, y negative 4, and the parabola will go upwards. So it will touch the x-axis, and we can find the x-intercepts. To find the x-intercepts, we put y 0. So the equation is x squared minus x would be equal to 0. If you take x as a common factor, we will have x minus 1 equals to 0. So either x is 0 or x is 1. So the parabola will pass by this point and this point. This is 1. So it will go like this. Well, he needs the graph from 0 to 2. If we put 2, if we replace x by 2, this is 4 minus 2, 2. So at 2, the graph will be equal to 2. 2 would be somewhere here, okay, if we take the same unit of measure. So part of the graph, okay, if this is 1, this is 2, it would be here. So part of the graph, this is the parabola. It will go like this. Okay. Now from 0 to 2, evaluate the Riemann sum for this function from x equals to 0. So to 2, this is 2. This is the line x equals to 2. So we need to find the area of this region and the area of this region. Now, if we use 4 subintervals, then delta x would be 2 minus 0 over 4. So delta x is half. So we can find R4. Delta x is half. And we will divide the region into 4 rectangles. So this is one rectangle, and here another one, and 1.5. Okay. Now, if we use the right endpoints, so this would be the first rectangle, and this would be the second, and this would be, now if we use the right endpoint, this would be the third, and here the rectangle would be just a line, nothing, because we will use the right endpoint. So we will have f of half. This would be the height of the first rectangle. F of 1, the height of the second rectangle. F of 1.5, the height of the third rectangle. And f of 2, the height of the last rectangle, the fourth rectangle. Notice that f of 1 is 0, okay? So that's why this rectangle is just a line, okay? Now how to continue? We just replace, we find f of these values using the definition of the function. So f of half is just -1/4. We found that. And f of 1 is 0. F of 1.5, 1.5 square minus 1.5. So that's 0.75. And f of 2 is 4 minus 2 is 2. So if we add, this would be 0.75, this would be 2.5. So 2.5 over 2, 1.25. So the area would be 1.25. And this would be the difference between the net area. So Riemann sum represents here the net area between this region above the x-axis and the region below the y-axis. So here, this is the rectangle we used. This is the second rectangle. And here it is the line. And here, this rectangle. Okay. Now, if you find the integral of this, the actual integral of this function, either using the formulas, we know the laws, or quickly I can use the calculator from 0 to 2. The answer in the calculator is 0.7. Okay, our answer is 1.25, and the accurate answer, the exact answer is 0.7, which is okay. It is a good approximation anyway for this area. Use the definition of a definite rectangle with right endpoints to calculate the value of this integral. Notice here he's asking about the definition of the definite integral. So we know that the definition of the definite integral, it's a limit sum. So we know that b f of x dx equals to the limit when n goes to infinity, summation I from 1 to n, f of x I delta x. So this is the width, this is the height, and we have nth rectangles and n rectangles, and we are taking the number of rectangles to be infinite. That's in this way we find the definite integral. So let us find, so when he says the definition, we use this, this definition. So delta x is 2 minus 0 over n, and xi, by definition, it is a plus I delta x, and a is 0, so it's 2I over n. Now f of xi, this is the function, so this is xi, so it would be 2I over n squared, x squared, minus x minus 2I over n. So it is 4I squared over n squared minus 2I over n. This is f of xi. Now let us find summation f of xi times delta x from 1 to n. So this would be equal to, delta x is 2 over n. I can take it out of the summation. And then I will have summation from I from 1 to n of this. which is 4I square over n square minus 2I over n. Now from the properties of summation, I can distribute the summation. Summation of the difference will be difference of summations. So 2 over n times, also I can take 4 over n square outside, okay, times summation I square minus this 2 over n is there, and I'll bring this 2 over n outside, and I will have summation I inside the integral. So this 2 over n would be distributed in both terms, and 4 over n square comes out here, and 2 over n comes out here. Now I will have 8 over n cube if you multiply these two. Summation I square, I have a formula, n times n plus 1 times 2n plus 1 over 6 minus 4 over n square. Summation I is n times n plus 1 over 2. Okay, and this would be n cancels with n cube here. 8 over 6 is 4 over 3. So I have 4 over 3, and I have here n plus 1 times 2n plus 1 over n square. And here 4 over 2 is 2, and n over n square, there will be 1 n here, and I have n plus 1 here. Now the integral would be equal to the limit. So I take the limit of this to find the integral of x square minus x dx from 0 to 2. It would be equal to the limit of this quantity. So I have, this is 4 over 3, not 4 over m. Okay, so I have 4 over 3, and when I find the limit of this, when n goes to infinity, I will take the highest power in the numerator and the highest power in the denominator, and then the limit would be 2. While if I find the limit of this one, of n plus 1 over n, I will take the highest power in the numerator, the highest power of the denominator, and the limit would be 1. So this is the limit of this, and this is the limit of this. So minus 2 times 1. So 8 over 3 minus 2. And this would be 2 over 3, which is the amount we found using the calculator. Use the fundamental theorem to check your answer. Well, the fundamental theorem of calculus says that to find integral from 0 to 2 of a function, you need to find the antiderivative of this function. And the antiderivative of x squared is x cubed over 3. And the antiderivative of x is x squared over 2. And then from 0 to 2. So now you replace x by 2. So 8 over 3 minus 4 over 2, which is 2, minus, you replace x by 0 to get 0. So 8 over 3 minus 6 over 3 again equals 2 over 3, and it is exactly the same answer. Here evaluate this integral by interpreting it in terms of areas, or actually use geometry, use a graph. Okay, use geometry to find the area, because you know a definite integral is just an area below the curve. To make it easy, I will divide this integral to two integrals, and I will find this integral by area and this integral by area. Well, the first integral, I have the function y equals x, and this is a straight line from 0. At 0, y, if x is 0, y is 0. If x is 1, y is 1, and that's the line, y equals x. So from 0 to 1, so I need to find the area of this triangle. So the area of this triangle is half times the length of the base. So this is 1, so the base is 1. And the height is also 1, so it is half. So actually this integral is half by the area, using the area or geometry. Now this function, I have y equals 1 minus x squared. And we know that if you square both sides, there is a square root here. If you square both sides and take x squared to the other side, then you will have a circle with center 0, 0 and radius 1. But since y is positive, so in fact, this function is represented by the upper half of this circle, the upper half of the circle. So he needs from where to where? The integral from 0 to 1. So again, from 0 to 1, he needs this part. Well, this part is 1 over 4 of the area of the circle. Okay, because this is the circle and this is 1 over 4 of the area. So what is the area of the circle? It is pi r squared. R is 1, so the area is pi. So the area of this or the value of this integral is pi over 4. So this integral should equal to pi over 4 plus half. Express this as a definite integral on the interval 0 to pi. So we will have a definite integral from 0 to pi. You know the definite integral is defined by integral f of x dx. And delta x will be dx. And f of xi will be f of x, will change to f of x. So this is sine xi, so it would be sine x. And the limit sum will be the integral sign. Okay, so that's the answer, integral from 0 to pi sine x dx. We expressed this as a definite integral on the interval from 0 to pi. This is integral from 0 to 6 of f of x, from 0 to 4, find from 4 to 6. Well, I have 0, 4, 6. So I will start from 0 to 6. I will say that the integral from 0 to 6 of this function equal to the integral from 0 to 4 plus from 4 to 6. This is a property. We can divide the integral using a number in the middle. So this is 10 as given in the question, and this is 7, and this is required. Let me call it, okay, what W? So W is 10 minus 7, which is 3. So integral f of x from 4 to 6 should be 3. Evaluate the integral if it exists. I have 1 minus x to the power 9, so I will take u to be 1 minus x. du would be negative dx. Differentiate, find the derivative of this. So this integral would be, I need minus sign here, so I'll put it here. I need also to change the x values to u values. So if x is 0, put 0 here. U would be 1 minus 0, which is 1. And if x is 1, u would be 1 minus 1, which is 0. So I will have negative integral. 0 will go to 1, and 1 will go to 0. negative dx is du, and 1 minus x is u to the power 9. So the integral of u to the power 9 is u to the power 10 over 10 from 1 to 0. So I have negative 1 over 10. 0 to the power 10 is 0, minus 1 to the power 10, which is 1. So the answer is 1 over 10. Well, here I cannot take this as u because I don't have the derivative of this outside. So the easiest way to solve this problem for me is to expand this binomial. So this is u to the power 1 over 4. If you raise it to the power 2, it would be u to the power half. Or you can write it square root of u plus 2 times u to the power 1 over 4 plus 1 square. And now you can continue easily. So this would be y to the power half plus 1, which is 1.5 over 3 over 2, or multiplied by 2 over 3 from 0 to 1, plus 2 times u to the power 1 over 4 plus 1. So that's 5 over 4, or 1.25 over 5 over 4, or multiplied by 4 over 5, taken from 0 to 1. The integral of 1 is u from 0 to 1. Okay, I have 2 over 3 here, and 1 minus 0, so it is 1, plus 2 times 4, 8 over 5, and 1 to any power is 1 minus 0, so that's it. And here 1 minus 0 is 1, so that's the answer. You can add the numbers and write the answer. Okay, it is 49 over 15. That's the exact answer of the integral, the exact value of the integral. Well, here the derivative of 1 plus u cube is outside, so du would be, derivative of 1 is 0, 3y squared du dy. Well, I have y squared, so all what I need is 3 and 1 over 3 outside. Now I need to change the values from y values to u values. If y is 0, u would be 1 plus 0, 1. And if y is 2, u would be 1 plus 2 to the power of 3, 8, so it's 9. So this would be 1 over 3 integral from 1 to 9 instead of 0 and 2. And now 3y squared dy is du. And this is square root of 1 plus y cubed is just u. The integral of u to the power half is u to the power 3 over 2 over 3 over 2 times 1 over 3 outside from 1 to 9. So this is 2 over 9. And if you raise 9 to the power 3 over 2, you get 27. 9 to the power half is 3 to the power 3, 27. And minus 1 to the power 3 over 2 is 1. So I have 2 times 26 over 9, and this would be 52 over 9. Well, I will take u here to be t minus 4. Then du would be equal to dt. So, and let us change the t values to u values. So if t is 1, u is 1 minus 4, which is negative 3. And if t is 5, u is 5 minus 4, which is 1. So this integral would be integral from 1 goes to -3 and 5 goes to 1. dt is du and t minus 4 is u and square is there. So this can be written as u to the power -2 and the integral is u to the power -1 over -1 or multiplied by -1 from -3 to 1. So it's -1 over u from -3 to 1. So it is negative. Replace u by 1, so I have 1 minus 1 over -3. So this would be 1 plus 1 over 3, which is 4 over 3 times minus. So the answer is -4 over 3. Well, there is no, I cannot take u as z here, that it doesn't do anything. And I have z squared plus 1. So the best way to deal with this problem is just to distribute the numerator over the numerator. So z squared over z plus 1 over z. So it would be z plus 1 over z. And the integral of z is z squared over 2 from -2 to -1. And the integral of 1 over z is ln absolute value of z from -2 to -1. So this would be half times -1 to the power 2 is 1 minus -2 to the power 2 is 4 plus ln absolute value of -1 is 1 minus ln absolute value of -2 is 2. So -3 over 2, ln 1 is 0 minus ln 2. So this is the exact answer. Now, this should be x squared. This is a mistake, typo mistake. It should be x squared. And notice the difference between this function and this function. Here x squared plus 1 is in the denominator, so I will take it as u. But here x squared or z squared plus 1 is in the denominator, so it will not help to take it as u. I should do it like this. So du would be 2x dx. Well, I have x, so just multiply by 2 and half outside. And then the integral would be half integral 2x dx is du, and x squared plus 1 is u. And the integral of u is ln absolute value of u. And then you just write the value of u, which is x squared plus 1. So this is the answer. Here we have x squared plus 1, but nothing up. So if you know the formulas, this is in fact tan inverse x plus c. This is just a formula. Integral 1 over x squared plus 1 is tan inverse because the derivative of tan inverse is 1 over x squared plus 1. Well, here I take u to be in the radicand in the denominator. Du would be the derivative 2x plus 4. If you notice, if you take 2 as a common factor here, then actually you need to multiply by 2 here and half outside. So 2x plus 2 dx would be du. And this is the square root of u. It would be u to the power -half when you take it up. So u to the power half over half or multiplied by 2. And I have half So they will be cancelled, and I will have square root of u, or square root of x squared plus 4x, because this is the definition of u. Don't forget plus c, plus c. Okay, here also we found the integral, so plus c. U to the power negative half, good. All right. Well, look carefully. I have tan multiplied by ln and then cosine inside the ln. And we know with substitution, we take a function which is inside another function. So we take u as cosine x. Well, du would be the derivative of cosine is negative sine x dx. Now, what do we have? We have integral. I will write tan as sine x over cosine x. And once you write tan as sine over cosine, you will notice that I need negative sine x dx. There is sine x dx, so I need a minus sign. And cosine x is u. So this would be, I have a negative sign. Negative sine x dx would be du. Let me write it here. And I have ln cosine, which means ln u, over u, because cosine is u. This is a nice question, so I will just call it additional, okay? Additional exercise. Now, this integral, I need to use substitution again. So I will take w to be ln u. dw would be the derivative of ln u, which is 1 over u du, which is here. So this integral would be equal to negative ln u is w, 1 over u du is dw. So the answer would be negative w squared over 2 plus c. And then w is ln u, so it would be negative half. And w squared is ln u squared plus c. But u is cosine. So this would be the final answer. Negative half ln cosine x all square plus c. I will take u here to be 1 plus tan t. So du would be derivative of 1, 0, derivative of tan is secant square t dt, which is this one. It's a definite integral, so let me change the t values to u values. T0, tan 0 is 0, so u is 1. If t is pi over 4, then u is tan pi over 4 is 1. 1 plus 1 is 2. So this integral would be from 1 and to 2. 1 plus tan t is u to the power 3. Secant square t dt is du. So it would be u to the power 4 over 4, okay, from 1 to 2. So it would be 1 over 4 times 2 to the power 4 is 16, minus 1 to the power 4 is 1. So the answer is 15 over 4. Find the derivative of this function. Well, notice that this is an integral. So derivative of integral is given by the fundamental theorem of calculus, which says that the derivative of this function is just f of x. So f capital prime would be the derivative of this integral. And according to this theorem, the answer, this is f of t dt, and a is 0 and x is there, the derivative is there, so the answer is f of x. You just write f of t, with this one, you replace it with x. So you just write x squared over 1 plus x cubed, and that's the derivative of capital F. Well, if you have a function here, not x, then the formula would be, if you have gx here, f of t dt, the answer would be f of g of x times g prime of x. That would be the derivative. So g prime of x would be d by dx of this integral. So what should we do? F of gx. So we replace t by g of x, which is sine x in this case. So replace t by sine x, so I will have 1 minus sine square x and 1 plus sine to the power 4x. I did this one now. I need to multiply by g prime, which is the derivative of sine, okay, which is cosine x. So this would be the derivative of g. Now we have two functions. So I will write it integral from square root of x to a number, let us say 0, plus from 0 to x. And now I will write this, the first one, as negative integral. I will change the limits and put a minus sign. I can do that, properties of definite integral. So what is this up to now? This is y. I did not find the derivative yet. And now I'll find the derivative. And the derivative would be d by dx of the first integral plus d by dx of the second integral. And now I can use this formula to find the derivative of the two integrals. So here I will have negative. I replace t by square root of x. And I will multiply by derivative of square root of x, which is 1 over 2 square root of x. Remember that the derivative of square root of x is 1 over 2 times square root of x, plus the derivative of this, I replace t by x, multiply by the derivative of x, which is 1. So the final answer would be negative e square root of x over square root of x times square root of x is just x. And this is ex over x. And this was the last question. I hope you enjoyed this lecture. Thank you very much.